You are welcome to today's class with your teacher, Anakwa Christopher GK. You are a chemistry teacher. I would like us to enjoy the class together by first of all starting with this. Let's take a look at this. What could be this particular image? What could it be that this image is depicting to you? As we look at this particular setup, you will see a container. We call it electrolytic cell, which contains two metallic rods. We call them electrodes. One is positive, one is negative. That means one is anode, one is cathode. And inside a container, we have also electrolytes, that the liquid content there. And it allows the passage of electric current. And the electrolytes, which houses two electrode, is being connected to external power source called battery. And when it's being connected, we can see some discharge, some whitish particle and around the electrodes, which are the mass of the substance that are being deposited or liberated at the electrodes. And the laws in chemistry talk about the mass, the quantity of mass that will be deposited in reference to the quantity of heat passed. And this will lead us to that particular law in chemistry that talks about that. And that is the law of electrolysis. So our topic for today is the law of electrolysis. Laws of electrolysis is the topic. And it's expected that by the end of this particular class, you should be able to state Faraday's first law of electrolysis. By the end of the class also, you should be able to state Faraday's second law of electrolysis and now solve problems from these laws of Faraday. So we'll be taking them one after the other. Let's begin with the first law, Faraday's law of electrolysis. Faraday's first law of electrolysis states that the mass of a substance deposited or liberated at the anode or at the cathode, which is electrodes, during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. That the mass of a substance that will be liberated or deposited at the electrodes, that they are being directly proportional. They are directly proportional to the quantity of heat being supplied or passing through the electrolyte. What it means is this: since it's directly proportional, means that if high quantity of electricity is being supplied, the mass of the substance that will be deposited will also be high. But if the quantity of the heat electricity supply is small, the mass that will also be deposited will be small. So it's directly proportional. It can be represented mathematically this way. If mass is being represented as M and a Q is for the quantity of electricity, we can write the first Faraday's law of electrolysis this way. M is directly proportional to Q. But at the same time, quantity electricity is current times time. If that is the case, we can state Faraday's first law as M varies directly as IT, since IT is current. And when we remove the sign of proportionality, we introduce E, which is electrochemical equivalent. That is to say that M is equal to EIT, where E is a constant and is also known as electrochemical equivalence of a substance. That is Faraday's law of electrolysis. And with this particular formula, we can use this to solve some issues or problems pertaining to first law of electrolysis, which will also give a basis to link other equations that you can also use to solve it. Now, let's look at second Faraday's law. Faraday's second law of electrolysis states that when the same quantity of heat, the same quantity of electricity is passed through different electrolytes, that the relative number of moles of the element deposited are inversely proportional to the charges on the ion of the element. The same quantity of heat or the same quantity of electricity is being passed through different electrolytes this time around. That the number of mole of the element deposited are inversely proportional to the charges on the ions of the element. If we use N as the number of moles and C as the quantity to represent charge, we can write it mathematically this way, that N varies inversely as C. That means N varies 1 over C. That is the mathematical way to represent Faraday's second law of electrolysis. When you remove the sign of proportionality, you're going to have N equal to K all over C. That is the sign of inverse proportion. N is the number of mole, C is for charge on the ion or valency. K, if you make K the subject of formula, which K is constant as we know, it will not be NC, second Faraday's law of electrolysis, but that is for one electrolyte, one system. If you have more than one system, 2 or 3, because when the same quantity of heat is being passed through, electricity is being passed through different electrolytes. Second system, third system, we are going to have N1, C1 equal to N2, C2 equal to N3, C3, etc. Depends on the number of electrolyte or system that is being set up. And that is for second Faraday's law of electrolysis. So with this, we are going to look at some examples or problems that pertain to first Faraday's or second Faraday's and get them solved. So let's take a look at the first question. Wire question 2003 number 4D. Question says, calculate the current in amperes that will deposit 8 grams of calcium from fused calcium chloride in 1 hour, 15 minutes. Relative atomic mass of calcium, as we know, is 40. And when 1 Faraday is 96,500 coulomb of electricity. Now, from that, one thing you must know, you must learn, and you must do in order for you to calculate issues that pertain to Faraday's law is you must learn how to write the equation, half equation, or the equation of the particular ionic equation of that. Now, we know that copper is in group 2. It loses 2 electrons. So you have to write it this way. Calcium 2 ion, removing 2, receives 2 electrons when he gets to the cathode. Then in order to have a calcium neutral atom of calcium. So the equation must have to be written by you. And if you don't write it, you find it difficult to know the number of electrons or number of Faraday that is required or being received. So with that, we can say from here now that 8 grams, which is 1 mole of copper, deposited 2 Faradays. That means 2 electrons here require 2 Faradays in order to be neutral calcium. 2 Faraday, 1 Faraday is 96,500. Then 2 Faraday will now be 2 times 96,500. If that is the case, how many grams will 8 grams, how many coulombs of electricity with 8 grams that was given give to us? If we get that one, we are going to have 38,600 coulomb. That is the quantity of electricity that 8 grams requires. But we are asked to look for the current. So bring the relation, which is Q equal to IT, as I gave in the definition of first Faraday or the laws of first Faraday. Bring the relation and look for time. Look for current. Time is being provided. Time is 1 hour, 15 minutes. Now, 1 hour is 60 minutes plus 15 minutes on it, or plus 7, it will now be 75 minutes. Now, the 75 minutes times 60, it will now be 60. 75 minutes times 60 minutes, 60 seconds, that makes a minute. In order to convert it to second, multiply by the quantity that you have before, you're going to have 8.58 amperes of electricity. This is the current that the current in amperes that will deposit 8 grams of calcium from fused calcium chloride. This is WIEC 2003 number 4D question. All right, let's take another question. Number 3 of 2013 WAEC question. The question says, calculate the mass of copper deposited at the cathode when a current of 0.2 amperes is passed through a solution of copper 2 tetraoxide 6 for 35 minutes using copper electrodes. Using copper electrode. So the same question, just like the first one we did. This is WAEC question. You need to write the equation for copper. Copper is copper 2. Is already in the question there. Copper 2 tetraoxide. So copper is copper 2. It will receive 2 electrons. It receives 2 electrons in order to be discharged or deposited as copper atom. And if that is the case, quantity of electricity, current was given, time was given 35 minutes. Multiply 60 seconds, so that in order to convert it to seconds, and you're going to have 420 coulomb of electricity. Then, if that is the case, we saw here that 2 farad is required, which is 2 electrons. That 2 electrons is 2 times 96,500. It's equivalent to 2 electrons, which is also equivalent to 1 copper we can see in the equation, and 1 copper is 64 grams. If that is the case, how many gram will 420 coulomb give to us? You have to just cross multiply. And when you cross multiply, you divide and have 0.14 gram of copper as a quantity of copper that will be deposited in the question given to us. That is it. That is method 1. Just like we did before. Now I will use method 2 now, formula method, to get this thing solved. So any of them you can use, and any of them is approved and acceptable in both internal and external examination. So let's use the formula method to get it solved and see what if we arrive at the same answer. Small m is for mass of the substance. Capital M is molar mass or relative atomic mass of that particular element or substance, equal to IT. IT is quantity, as we know, Q. C, small c, is for the number of charge, which is the electron. F is Faraday, is constant. Now, the values we are provided, and we are asked to look for small m, which is mass. You substitute accordingly. Time is 35 minutes times 60. And from there, when you substitute to make small m the subject of a formula, and when you make small m the subject of formula, the same value, 0.14 gram of copper, will also be realized as your answer, as the value or the mass of copper that will be deposited. The same answer. So any method can be used. You can use any of it, and you arrive at the same answer. All right, let's take another question and see what will become of it. This is number 1 of 2014 WAEC question. It says, calculate the amount, this one now, amount of silver deposited in 1 mole in moles, amount in moles, when 10,920 coulombs of electricity is passed through a solution of a silver salt. You just need to bring out the equation once again. Silver is 1. You just put the equation, or it receives 1 electron to be silver atom or silver solid, and you get your calculation done. You can use formula method. You can use whichever way to get it solved. With this, from this equation is very, very simple. 96,500 coulomb, that means 1 electron that silver received. We can see it that it deposited 1 mole of silver from the equation. Now, how many will 10,920 coulomb of electricity that was given in the equation? How many the quantity of 10,920 coulomb? What mass will it deposit? Mass of silver that will it deposit? Cross multiply, and when you cross multiply, you are going to have 0.113 mole. 96,500 coulomb of electricity deposited 1 mole of silver from the equation for the reaction, or equation we can see now. Now, what is the number of mole? 10,920 will give us. We cross multiply, divide, and you have 0.113 moles of silver. That is the question. And let's take another question as we'll be tidying it up. This is question 1989, number 13. This question says 0.22 gram of a divalent metal is deposited when a current of 0.45 ampere is passed through a solution of its salt for 25 minutes using appropriate electrodes. Calculate the relative atomic mass of the metal. Now, the particular metal is not given to us, but he has given us clue that is divalent metal. That means 2. So with that, we're going to get the equation and use either whichever method we want it to use. Formula method it could be used. We use it to solve it. And that, if that is the case, get your equation 2 ion, and you get your equation by using formula method, which I wish to use. M small m all over capital M equal to IT all over small c capital F. The formula, the values we are given except the capital M, which is the relative atomic mass of that particular element. And when you substitute, you make capital M, which is relative atomic mass, the subject of the formula. Make it the subject of formula, substitute rightly. And you are going to have 63.5 gram, 63.5 gram of the particular metal that was deposited during such kind of electrolysis. So that is the value, and it was given in Y question. All right, this one, you are going to do this one as your own assessment or assignment. A current of 0.72 amperes was passed through dilute tetraoxide surfaces for 3 hours, 20 minutes. Calculate the quantity of electricity that was passed. WIEC 1999, number 4. That is it. Number 2, calculate the quantity of electricity used during electrolysis when a current of 0.21 amperes flows for 2 hours. WIEC 2005, number 4. And lastly, 0.45 gram of a metal M was deposited when a current of 1.8 amperes was passed for 12 minutes. For 12 minutes through a solution containing M2 plus. Calculate the relative atomic mass of M. All these are just almost the same thing with what we just did now. Do this, and for further studies and contact and other things, discussion, you can make use of your essential chemistry, understanding chemistry, new school chemistry, then compile past questions. If you want to contact me and for further inquiries, you can contact my WhatsApp line 08065573229, and then or you can email me at crystal116@gmail.com. All right, thank you for listening, and